Okay, so you understand the way you'll be get back to the lab very soon. For take you, your guy will be get everything you need to do at home. That means we given to you the test set, power supply, a meter, wiring the IC, okay, everything neat so you can be at home and verify on the Zoom. So I hope that will be help for any student from last spring. If we are able to do the lab, then that's why you're able to get the completion. So everyone have to understand you must be get on of assignment, take one and take two. Okay? So if you don't have any assignment, you upload it. I cannot give the certificate. Okay? That means you want to stay in a program with me. Right now, I have to working on how can we get everything for the guy. And also have to be, try to see how can we can do, set it up for take one. Okay, before we start something else, I want to ask you something. On your homework, and you say you get this grade here, okay? And I asking you, I get zero here and the output zero. The question is, what the input here requirement? You can enter zero, one, don't care.
Don't care.
So the answer must be don't care. Okay? If it one is correct, it's still working. However, I asking for requirement. What that means? That only telling you one thing. If input is zero, okay, zero here, and the output is not zero. So you have to check this pin right here for logic zero. If there is zero here, then you change the gate, okay? Change this gate, they not working. You cannot say you can check on the other one. The thing is, and gate one input zero output must be zero. If you say you check the other input for logic one or zero, that means you not understanding. Okay? This is a logic. Logic, that means you're not doing any extra work. Cannot be accepted. Okay? And now, if you get this gate here, What equation?
Not A, B.
Okay, you say not A and B, not right?
Yeah.
But I want this one. You have to break it out. Not A.
Or
Not B.
not.
That is what I want. The thing is that easy for me to telling you what output. Okay, so if A0, what output?
Don't know.
Ah, come on, man. A equal 0, not A equal what?
1.
1 and you all with anything. They must be 1. That's only telling you for the NAND gate. 1 input 0. Output must be 1 no matter what. You don't care about B. However, if I said, if you get a 1 here, what out?
You don't know.
You don't know. The answer is right. The thing is 1 in here, not A1 is 0. And all with not B. If you don't know B, you cannot tell what output. If you get a 1 here, then you get 0. The thing is you must be understand this thing. We will be going to the flip-flop. If you don't know how the NAND or the NOR working, it's hard to understand the next one. Okay? So basically for the NAND, if you look it back, and you must be understanding 1 input 0, output must be 1. However, output will be 0 when the on of the input must be 1. This is the NOR. What y equal?
Isn't it the same? Not A plus not B?
Now, in order to write the equation, first thing you have to say, forget this bubble here. Then they will be R, right?
Okay.
A or B.
A or B.
Okay, so you can say A or B. Now you get the not here. Then you put over not. But this equation, I don't want it. I want a little more. Equal what?
A and B were not over both of them.
Not A
I'm not B.
and not
And not
B.
B.
Okay? So, if I get A equal 1, what out?
Zero.
They must be 0. The thing is A equal 1, not A equal 0. 0 and with not B, they must be 0. So this is for the NOR gate. One input to one output must be 0. In order for the output to be a 1, then A0 here and B must be 0. Okay? A0, then that not A1, and B0 not B1. So that's why you get 1. So for the NOR gate, if a one input in logic from one output must be 0. You don't care about the other input. However, for the output to be 1, all of the input must be 1. These are two very important gates. When I given you the input, you can telling me right away what is the output. That be okay. In order to understand for the next. And the other thing, nothing like you get a exclusive or AB output Y. Okay. When the output Y equals 0. Exclusive or.
When they're both 1?
What my question is, you get exclusive or input AB. I want output is 0. What the input to take?
Zero?
Come on.
It's when they're both 0 or both 1.
That means you have to say input the same, output 0. That means A0, B0, out 0. A equals 1, B equals 1, Y equals 0. Input the same logic. Output will be 0. Input different logic. Output equals 1. That means A0, B equals 1, output 1. A1, B0, output 1. B1, A0, output 1. Different logic, input, output equals 1. Same logic, output is 0. You want to be a technician, and this is a basic thing, and you cannot answer. How? I given you the handout, you have to read it. Try to understand, and anything not quite understand, bring it up. Otherwise, you just wasting your time. Only how many get? You can get AND or NAND, nor inverter, exclusive or. And exclusive nor just opposite to the exclusive or. Most of the get will be C, will be the NAND, nor, and or inverter. Okay, any question on this thing? Nothing? Okay. Today, we have to concentrate on the way we'll be doing the lab. Okay, the thing is very soon we must be doing the lab. If we get the truth table, C, B, A. That means input and you get Y out. For the truth table, you get CBA 3 input. How many combinations? 0 and 1. Okay, CBA, how many combinations for 3 variables?
16.
Ah, come on, man.
8.
8. I said if you're looking into that, okay,
2 to the n, and
go
n
to the
equals 3.
power, 2 power of 3. You get 8.
Right.
That means 3 variables. If you get 4, 2 power 4, you get 60. If you get 2, you get only 4. Okay, now we get 3 variables, A, B, C, 8 combination. The first one you can get 1, 2, 3, 4. The next one will be 4. 1, 2, 3, 4. And the second one, 2, 0, 2, 1. And the last one will be 0, 1.
1, 0, 1.
Okay, so now you get at the truth table. So you see that the circuitry be given to you. So for each combination of 0 and 1, you need to calculate it to see what y equals. Now I can try the first one. You get 0 here. Okay, 0, 0. What out here?
0,
I'll put here.
0.
0. Correct. 0B, 0C, you get 0.
0.
0, 0 for inclusive.
0.
So that output you get 0. Okay, you get that?
Right.
Yes.
Okay, now go to the second one. The second one, A0, A1. 0. 0. Tell me what out?
0.
0. Perfect. Okay, the next one you get 0, 1, 0. Okay, now you get
1.
0, 1, 0. What you get?
1.
Perfect. You get 1. Okay? That means you have to go in from the first to the last one. Substitute into the circuitry. Find out what output Y equal. That's what they call analyzing circuit. Do you follow it?
Got it.
Okay, now, however, we want to tell the PSPI simulation do it for you. Instead, you have to sit there and substitute the value and try analyze the circuit to calculate the output. Take a lot of time. So that's why they get a simulation using PSPI. Okay? Using PSPI, first thing, the first step is draw the circuitry. That's easy. Not a big deal. However, what PSPI will be doing for you? Who can answer that? What the simulation will be given to you?
A way to see if you can simplify the number of gates?
Now, my question is, you using the simulation for what purpose?
It speeds up everything. It's a lot faster than doing it by hand.
Okay. That's only telling you one thing. We need the simulation so you can get the output. Right?
Right,
Without you have to do in your calculation.
right.
That is the purpose. Okay? You can sit there and try to calculate it. You can get the output, but it's not the way. They get the program by helping you. If you run the simulate for the circuitry, they telling you what output for each combination of the input quickly. So now you understand the purpose of the simulation. Okay? For the simulation, you already know PSPI. Draw this circuitry very simple. But the big thing here is you need to apply the input A, input B, input C, so they can do the calculate for you. Now, in the PSPI simulation, if you apply input A, you have to send the waveform A. Input A, waveform. Now, if you look in here, A start 0, then 1, right? Then 0. So the waveform will be look like 0, 1. Zero. 1. Keep going. Okay. How many? 0 here. 1 here. 0 here. 1 here. How many will be done?
4 clocks?
Keep going. Okay. And now, if they say I given for each transition is 1 microsecond, that means from here to here. One year, 1 microsecond. So the second one, B, I want to see, draw B waveform. So B will be 0, 0. How many microseconds?
2.
2. 0, 0, then 2, 1, 1. So you can go 0, 0. And you go 2, 1. Then you go 2, 0. Then you go 2, 1. That means 0 here, 0 here, 1 here, 1 here. So on. That's the signal for B. How about C?
4 zeros and 4 ones.
4, 0. The thing is 1, 2, 3, 4. 4, 0. 4, 0 here. It's 0, 1 microsecond. Okay? So basically they get 4 microseconds. Okay? So any question how to converting from the truth table into the waveform? The PSPI cannot understand 0 or 1. If they get a signal, waveform, then they can understand. So that I just converting from this to table here into the signal ABC. Any question? I said if you not understand, you have to bring it up. That's at the beginning.
Mr. Pham, Marcelo here. One question.
Yeah, go ahead.
Are we going to create the breadboard, the circuit on the breadboard, or only are going to use the PSPIs to simulate the circuits this quarter?
No. They did on the process to get the output of the circuitry. After you done for everything, then you can build.
Okay.
That the process to building the circuitry will be the last. Okay?
Okay.
My question now, if we get a truth table, you know how to converting to the waveform for 0 and 1. Okay, so in the page 5, you can see later on, you get what they call an include file. This file will be helping you to tell the PSPI this is the input of your circuit. Okay? The key point in here is the include file. The other thing will be very easy. Draw the circuitry, run the simulation, not big deal. But the include file, that is the file of your input applied to the circuitry. If you get a right input, then you're able to get a right output.
And that file is provided by you, Mr. Pham?
This file,
The include file is provided by you?
yeah, will be saved.
Okay.
Okay, will be saved. But then you have to get the waveform. Okay, and include will be do it for you. Now, this is the circuitry here. Like this is the circuitry will be sent out to you to do the lab. When you're looking into this circuitry, can you tell me how many inputs?
4.
4. Okay. And the name input 1 is PA.01, PA.02, PA.03, and 4. Okay. And you're looking into this circuitry. How many outputs?
1.
1. PC 01. 1. Okay. How many gates for this circuitry?
3.
3.
3. Okay. How many IC?
3.
3.
3. You
No.
can see the first one named gate, part number 7400. The second one will be OR gate, part number 7432. And the last one will be inclusive OR, 7486. Okay? So now, when you get into the PSPI, easy to get the part, easy to draw the wire. Only thing is when you get the connector PA.01, you need to using Robo. Okay? And then also you need to get the include file. What I want you to do now, go ahead and get into your PSPI. Draw that circuitry for me. You can get about maximum 10 minutes. Only 3 days. Go ahead and draw it. You must do it. I think I did. Thank you. It's not too many students. Easy for me to control. Easy for me to know who do it, who not do it, who can do or who cannot do. think when we start doing for the lab, you guys get a 1-day lecture on Tuesday. However, you can get more time on Zoom with me to verify your work.
486.
Make sure you can draw that circuitry quickly. You are already tech two. That means you already know how to working with PSPI.
One, two, three, 4, 5. Delete.
Who already done for drawing?
Almost.
1 second.
2 seconds.
I'm looking for comb. Humi.
Yes. Not here. Almost done.
Now is the time for you guys to ask any question. It's still confusing. We must be understand. Oh, one student asked me what book do I teaching for this course? I don't know. Too many. Not only one book. Only thing is what I want, using my hand out. You get through that, you understand that, you'll be okay. I combine too many different books. Okay, someone already tell me done. Okay, now I go to the next step. Only on this drawing here, we concentrate on include. Okay, you need to attribute for include the first thing. Double click on the include. And on that, you select file name and typing C/ETT/sample circuit.stm and save it. And they must be displayed exactly what I'm doing here. That means if you're doing okay, they will be displayed exactly here. CETT sample circuit.stm.
I think I'm there with you, Mr. Pham.
You're already there, right?
Yes, sir.
Very good. Okay. Yeah.
Oh. I got it here, Mr. Pham.
Yeah, then what?
Did you see it?
Okay, Adam, right?
Yes, sir.
Okay. Again, I want to make sure you understand. I really want your guy to be a good technician. So that's why. This time, I really go more detail to helping you to get a basic understanding. Okay, now, let's see, next one. Now, you can see this is the signal. Okay, let's see. I can give one example here. Okay, that will form for 1 microsecond. So if you want to edit your include, okay, you need to double click on this file here. Double click, okay, then click that. So they will be going to the file for you to edit. And now if you get this signal this way, okay, then the way in order to do on the include, you need to type in. First thing they say, first thing you can see, they say add one, okay, and they can say steam whatever. We'll be see later, 1 and so on. This just exactly formula, okay. Only you can change will be add one. That for the first input, okay. Then on the first one, this is the formula. You can see they get a plus sign here. Then you say your input A, then have to be A here. That means they must be matching with your circuitry in the PSPI. Like
So-
here you say you using PA that 01. Then in here you must be PA that 01. They have to be matching. Okay. If you get PA that 01. Okay. This is just a formula. And the next, they will be a next one. Okay, they can say I or whatever, this formula. You don't care. And the next one, plot here. They get 0 at. 0 at means at the beginning here. What logic?
0.
0. Okay. Then you can see a next one, they get double blood. Double. Okay. And they asking you at the beginning, they will be 0. How long? They be
Microsecond.
0.
After 1 microsecond, it changes to logic 1.
Right. So that means 1 year. And they go to 1. Okay. And now, after 1 microsecond go to 1, then 1 microsecond they go 0 and keep going. You don't want to type in everyone. So that's why they're using the formula. Okay. They say, okay, repeat forever.
And Mr. Fan, what does it mean the plus and the plus plus?
Formula.
Yeah, I understand it is a formula, but what does it mean inside of that formula?
I don't know. That is the formula. That is the formula you must follow. Okay? Like, when you're writing the software C++, at
Does
the
it just
end,
mean
at the end of statement, you must be get a semicolon. That's a formula. Cannot
the-
be answer.
does the plus plus just indicate that it refers to time moving forward? It's a forward increment of time.
I don't know. I
Okay.
have no idea. Okay. Now, after the 0 and 1, and they repeat the same thing. So that's why they're using formula. Repeat forever. That means keep doing the same. Okay. Then you can say blah blah 1 you add for logic 0 and 1 you add for logic 1. And then you have to get what they call and repeat. Okay. Now, I want to try on this signal. I given PA01. Okay. And you need to typing into your Inclu file. First thing you type exactly is S1. 11 G power G round. That means you tell the PSPI apply power and round. The next will be the name. If you're using PA101, then in here must be PA01. Okay. Now, at the 0 at what logic? 0 at means at the beginning.
1.
1.
What the logic?
Logic 1.
1. Okay, you see 1 right here. How long they stay in 1?
2 microseconds.
2. So you will be 2 microseconds. Then they go where?
Logic 0.
0. How long they be 0?
1.
1. They go to
1.
1. Right?
Yes.
Okay. How long should stay 1?
1.
1.
1 year. Then they go.
0.
How long they 0?
2.
Then they go.
1.
That is correct. This is an input to your circuitry. I don't care what is in the truth table. I given you different type of the input. Make sure you can get 10101 when you typing into include file. Okay, now second one, PHO. Then you understand we already put for you PHO right here. Okay, already PHO. So at the 0 second, what logic?
On.
Okay. Logic 1. Okay. How long they be in 1?
1.
1 micro.
1 US.
1 US.
Then they go down to
0.
0. And now they keep repeat the same thing. So that's why they're using repeat forever. Okay. What they want to repeat is repeat 1 then 0. So 1 U for 1 and 1 U
0.
for 0.
Hey, Mr. Pham, I'm sorry for this question, but where do we have to enter this, type these zeros and one? You said that you are going to provide the include file. And where do we have to work with that include file? Into PSPice?
When you double click on the include file, once you have it on your program, it will open up a notepad page.
Okay, I can give you an example.
Thank you, Mr. Pham.
Let's say piece by simulation. Okay, so now I need to using my desktop. I want to stop that guy. You see that?
Yes.
Yes.
Okay, you see that when you open, double click your include, then they will be open notepad. Now, this is what you need to typing in. Okay, this is just, for example, 0S, you get logic 0, 1 0, you get 1. And if they repeat, you typing repeat forever. What they repeat, 1 0, 0, 1 0, 1. And repeat, you done with the number 1. Then you start with number 2 waveform. Then 3 waveform. And 4 waveform on this example. Normally, you done for the first one, you copy US1 to paste them out. I given you the example. You can copy everything. Copy and paste them out. Now, U10 must be US1, no more, have to be 2. Next one have to be 3. Next one have to be 4. And the pin here basically depend on your circuitry. In this sample, you say PA.02. IO line cannot be changed anyway. And also, you following that and add it for your timing. However, no matter what you do, okay, when you go to file, you must be say, okay, cannot be say F. This is a project. If you say S, they not inside your project. And that's why you get error. Okay, only say. Okay, so now I go invite. With that circuit.
So Mr. Pham, if I understand well, that code is the code that we are providing to PSpice to generate the square wave that our circuit is going to use, right?
That means you given the waveform for input
Okay, got it.
to the PSpice.
Got it.
Okay? And they
And-
will be telling you.
Okay, last question, just curious, what kind of code is that? I mean, which kind of language is it? It is C, C++? What kind of?
No, that means when you write the test program, will be C++ Visual.
Okay, thank you.
No big deal. Okay, let's see.
Mr. Pham,
Yeah,
in what position do you usually use this program? Like on a job, what kind of like field? Like is regular technician or?
no, that one is only technician, engineer, technician,
Oh,
and engineer.
I see.
Okay. However, what I'm telling you, even you don't have to write the program when you're working as a technician.
Okay, thank
Okay.
you.
However, in school, either college or in this program, they have to using the software to test to make sure you understand. Okay. And
Alright.
they're using the up-to-date software. That means C++.
Thank you.
Yeah, no problem. Okay, we done that one. We done that one already, right? No, that one not. That one we done. That one, first one we done. Next one we already done, right? You see the display?
Yeah.
Is it number 2 you done?
Sample.
Otherwise you have to copy it yet. Okay? The thing is you have to do it now. Now, again, that one you suppose to get what logic? Logic 1, right?
Mr. Pham.
How come I cannot enter? Let's see, I want to see why. Okay. So we have to get this thing for you. Okay, that one.
We still don't see it. We only see your first page.
Okay, now I need to say again. Now you see it?
Still the same.
Yeah, the same page one, right?
Page one, yeah.
Okay, now we go.
It's not going. It's still on page one.
Yeah, yeah. Okay, that will be page number 2.
Nope.
Okay, so if you, I already done that one, I given you the answer here. Okay, 1 U, 2 US, 0. Okay, 1 US, 1. 1 US, 0, 2 US, 1. Okay,
We still only see a page one.
Yeah, I can't see what you're talking about.
I'm talking about the, you must be enter that for your circuitry. PA pin 01. That's for in your include here.
We're not, I don't think we're seeing what you think we're seeing.
He's talking about the input.
Are you talking about the global? PA01?
Yeah, like the global.
What do you mean a global?
The PA01 and PA02, those stuff.
CA. Is it you see the waiver form?
Nope.
No.
No. How
You
come?
see the circuit.
It's still on the page one. The circuit.
Oh, okay, just a minute. I already unshare this one. Okay, so they're not sharing. And new share here. So this one is sharing here. So you see display for the waveform.
Nope.
No,
Uh-oh,
the circuit schematic is all.
still circuit schematic. Okay. Just a minute.
It's stuck on your PowerPoint presentation.
Okay. Okay, now I try to see. Okay, I stopped everything.
No, you're still sharing the screen somehow.
Yeah, still sharing, okay? And now, did you see Window Explorer, right?
No, we see the slide, the first slide.
It's still on your PowerPoint.
Yeah, PowerPoint, yes. Go
Oh.
to your desktop.
I don't have any more display on my screen.
You're still sharing that screen somehow. Oh, there,
Right.
there you go. It's gone now. Now we're good.
Now nothing, right?
Now we see
Okay.
you.
Let's see. I try to say again, okay? Is it you see the With
Yeah.
the plotter.
Yes.
Okay, that's good. Now you see schematic.
Yes.
Yes.
Perfect. Okay, so we try to get into the point. Okay. This is the answer here. For you guys to type in A, your include. Okay,
Got it.
now next one. On this number two, we already done. I given you the answer. First one, you get a 1. And the next will be 1 yield for 0, 1 yield for 1, 1 yield 0. But using repeat forever. Okay, that's what we already done. Now, this number 3, you do it for me to see how many people can get the right answer.
I think I have this part done, Mr. Pham.
You already done?
Yes, sir.
Wow.
Anything else need the time to do it? You must do by yourself to guarantee you understand.
Hey, Mr. Pham, is this basic thing, is this on the download that you told us to do at the beginning of the class?
Yeah, but the thing is you don't have an answer.
But I mean, we can look at it and if we know how to do it, we can figure out our own answer, right?
Yeah.
Thank you.
Okay, on that one, I given you the answer here. First one, 0. 0.5 yield, 1. 3.5 yield, 0. Then 0.5 yield, they 1. In order to make your PCPI working, this must be correct.
Mr. Pham, when you type in this number, when you type in plus 0.5 US and then 1, do you put a space in between or can you use tab?
Normally, you're using the space or pattern, doesn't matter.
Doesn't matter. Okay, thank you.
But on the other side, must be following the formula. Plus, double, plus. Okay?
Yes, I got that.
That's their formula. Only thing that you need to tie here, okay, 0 here. Then you say 0.5 US, 1 here. Okay? That don't have to be using the tab. You can use the tab if you want.
Hey, Mr. Pham, I got a question for you.
Yeah, go ahead.
Or anybody that might know. On the schematic, to get to this notepad, you have to click on the include. When I click on it, this little box comes up and it's with a yellow triangle and a quotation mark, and it says notepad, this system cannot find the path specified. Because what I tried to do is I tried to do save, not save as, and for some reason it keeps popping this little box up. When I get
you click on save, right?
Right.
Then what they said?
It says notepad, and then it's got that triangle and it says the system cannot find the path specified. Because I'm trying to use the notepad to do all of that stuff that you're doing.
Did you press create file? Doesn't it ask you?
No. When you first start off, what you do is you click on the include file, and then the notepad window comes on. Then I try to save a few things first. Just hit save, not save as, only save. And then it says system cannot find the path specified.
Okay, I see what you say. I'm telling you. Here. Okay, I say when you attribute include, they must look like mine. If you get a different, that means you get it wrong. They couldn't get that far.
Yeah,
So, Mr. Pham,
Yeah.
the way that that's written on the screen at the bottom where your cursor is right now is slightly different than the way it's written above that in the little window where it says file name and value.
Oh,
you have
if you double click on that include, first thing you have to double click on that include, and they display on that attribute here.
Yes, but I'm saying does
you have to select the file name?
Yes, I
and
understand.
Typing C.
Right there where your cursor is,
Yeah.
that file name is written slightly differently than it's written at the bottom of the screen. Is that an issue?
Now the same thing.
Okay.
Sample circuit.
Yeah, that's what I was going to tell you, Mr. Pham. I got everything just like you did, but for some reason that little box keeps popping up. So, but don't worry about it. I don't want to take up class time. I'll figure it out. But yeah, I get what you do. You click on the include file, that little screen comes up. You click on file, you type in the information, then do save. Okay, then you just continue with your typing your notepad.
Okay, now make sure you get the column /att/ sample circuit dot @tm.
Yeah,
So
I'm familiar with all of it.
They must be look like my here.
Yeah, I understand
that. Means the bar over ETT means directory.
Right.
Inside the C drive. And sample circuit means the name. STM means the type.
Yeah, I got you. I'm gonna try something else, but thanks a lot.
Okay. Now the thing is we have to get the quick, otherwise time it could really run over. Okay. Now this one here, okay, we done. And I given you the last one. That's the last one. The thing is you have to get this one. Then we can go with you in the real circuitry. Okay, I try to say page 5. Okay, now you can see my ear. Page 5. First thing you get this one, right?
Yes.
And you double click on that sample here.
Yes.
Let's see. How come we double click and they not display? It's supposed to display. So
Mr.
basically,
Pham.
I try to see where is it the file. Go to CETT. C drive, ETT, F25, right here. You see that? That is a file. So if you double click and click at yes, you can type in that in. After you done the first one, just copy and change whatever you need. Okay, I want to say
One more.
and now if you run the simulation, then now you can see I take it out here, take that out here. I want the input 1, 2, 3, 4, PC out. And you can see they will be displayed.
Wow.
That means the input you apply into the circuit. And now you can click on here. You can see the first tab input will be 110. Okay, 1. Output will be 1. And you go to the second tab here. Okay, output still 1. And you can go to the next one here. Output 0. You see that? That is the collect the output for each tab. Okay.
You started at 0, right?
Yeah, right here. You see on the left side. See
Mr.
that?
Sam?
Yeah.
So I've tried to get to there, and I did something wrong because my screen is gray, not black.
That
And-
means I'm wrong.
Yes.
And here is say not
Okay.
recognized.
Now, if you get something wrong and you can share screen, I can tell you what happened.
Okay.
I stopped there. Okay.
Thank you.
Yeah, you need to share your screen, the one that's got the circuit on it, because there's something on the circuit that's wrong.
Mine was great till I hit new in the stimulus window.
Maybe the coding.
So you double click on your CETT sample circuitry to see what happened.
Right here?
Yeah. Double click on that.
Double click what?
That one.
Oh, I'm sorry. Am I not sharing that?
Yes.
Okay.
You still on share. Double click on that. So they can bring up the file.
Here and then share the
There. And
desktop. There you go. Yeah.
Okay, 1, 2, 0, 1, 1, 0. EHO, PHO. Repeat forever. Okay, go to number 3. PA3. Okay, 0, 1, 3, 1, 1, 0. Okay, go to number 4.
there we have. I didn't finish.
Oh.
That's an easy solution then. Thank you.
What did he do on number 4?
I skipped it.
Now I did have number 4, but I still got a gray screen.
Hey, Mr.
Okay.
Bam,
Then
Mr.
you
Bam-
can share.
Okay.
Whoever you try to fix that first.
Let me get into the class with Zoom on my other computer.
So, okay, so they can unshare that, stop share, and you can share.
Okay, thank you.
Hey, Mr. Pham, I got a basic question on the guy that was just sharing his screen. I noticed when he put in UH1 and STEM and all that other stuff, he did it in capitals. Is that okay?
Can you say again?
The guy that was sharing the screen, yeah, he put like UH, like UH1, UH2, and all that stuff. He's got the U and the H is capitalized. Is all that, and the
That's
stem,
okay. I believe that's okay.
and those letters like DPWR, usually they were small letters. Is it okay for them to be big letters?
That's okay. They must be ES1, ES2, ES3, ES4.
But you can do capital or small letters.
Right.
Okay.
Uppercase, lowercase, big, no big deal. Okay, we'll see you tonight.
Okay. So I got the gray screen on the chart. So
Okay,
what did I do wrong here?
you're doing wrong. The thing is PC, you connect it wrong.
I can.
That's what the first thing I can see.
Which part is wrong? Can you point to me?
PC, they're supposed to connection on the other side. You cannot connect that way. You have to, you not have to double click in PC and rotate it
Double click on where?
on the PC.01.
PC.
Yes,
Rotate
that's
that.
Okay.
I mean, rotate it. The connection have to be, right now you on the right. They must be on the left.
Well, I don't quite understand what you mean by that.
You see the connection on the right.
PC01?
Yeah, but the connection on the right. You see the wire on the right.
Oh, this one?
Yeah,
Oh, so
they
it has,
must be on the left.
so it must rotate it. Okay.
Right.
Okay, let me delete that.
Rotate
do-
that.
Do Control R.
Hang on, let me press on that.
Yeah,
Control R.
Okay, now you connect.
Okay, now simulate.
Okay, and try to again.
Still gray out.
Okay, you still got a problem, right?
Right. So you want me to open up the Inclu file? What will it say here?
Let's say no recognize product.
Hey, Mr. Pham, see where he's got his U3, A, and then after the 3, is that wire is red, not black like everything else.
Because I clicked on it, I think. There you go.
Okay. And also too, when you built your program, did you, because I noticed, see like in the bottom left, where the box is at, where you scroll, if you go down.
Go down, left.
No, down, straight down.
Straight down.
Right, no, you, right there, right there.
Okay, hold on. Go back. You get out of the simulation. Go back to the setup.
Setup. Okay.
Go setup. Select transient.
Transient.
Right. Okay, only final time will be 10.
What's the final time? 10?
Yeah. Now, on this one, how many tabs?
2 to the 4. So 1, 2, 4, 8. So 16.
Okay, so you can enter about 16 yield.
16 U.
16 yield. 16 yield.
Okay.
That means 16 yield. 16 microseconds.
All right.
Let's close.
Close.
Now you can run.
And simulate. Yeah, look like I got something.
Okay.
It looked like it. And then chart.
Yeah. Remove that one,
the next
remove
one,
that
yeah.
one.
Yeah.
So you click input 1, 2, 3, 3.
4, and the output.
You right click it. I mean, every time you click one, it just changes. Oh, hang on, it's
No,
down.
no.
Oh, I
Try
see.
delete everything.
I got it.
Okay, click one first.
1,
2,
2,
3, 4. Output. Okay, that's okay. Now
got it.
you get it.
Okay, you did it. You did it.
Thank you very much.
No problem.
Let me unshare and see anybody else have problem.
Yeah,
Can I-
everyone get a problem.
Can I share again, Mr. Pham? I got my number 4 in.
Okay.
I have a basic question. From where can I download the code ETT sample circuit.stm?
Okay, just a wait minute. Solving for this problem here. Okay, now you run what happened.
I'm getting the gray screen again.
Okay, now I want to see that.
Unshare, and then when you share your desktop screen.
Okay.
Yeah, share your desktop screen.
Oh, I know what I'm missing. UH1.
Okay, so now you go back to your schematic.
You want me to share the schematic?
Yeah.
Okay, so now,
Suddenly not letting me.
so PA, not 1, PA 2.
I'm trying to share it and it won't come up.
Oh, how come?
Adam, when you press share, do you see something like a screen 1
Go to
on
PA
desktop? That's one of the screen.
0 second.
Yeah.
That 1.
Okay, you go to the setup, analysis setup, scan gen. Only gen will be final time to number 16 yield.
Oh, you know what? I need to go
You
back.
yes, that's correct.
Damn it.
Okay,
I'm not finished
now
yet.
run.
That worked. Thank you.
Okay. The thing is, your first lab, I will be telling you how do we set the transient.
I need to look at this. Forget about that.
That's perfect.
Thank you, sir.
No problem. Anyone else?
That's my first.
Kumi all done, right?
Not yet.
Come on.
You and me finished last week.
Still on take 2.
She just doesn't want to make the rest of us feel bad. That's all.
Yeah, you try
Let
like
Mr. Smith go first.
Kumi try to do the best. I can help you to get a job.
Yay, thank you.
Yeah, whoever in my class I know who can do, who cannot.
Thank you very much.
But Mr. Smith have to stay with me.
That's right, forever.
BFFs.
That's,
So that means I can get the first B lab will be upload very soon. You guys don't get much problem to do the lab. You can build and you can run. I will be allow you guys to get the box on Wednesday and return next week Wednesday. That means 1 week.
You're saying we get the box next Wednesday?
No. This week I have to go up to the class, try to see we set it up and try to see how many box we can get. The thing is, everything should be okay. The test box will be okay. I believe I can get 10. Wiring not problem. IC not problem. The tune how to do it, cut the wire, whatever, not problem. Only the problem I get will be the power supply.
Mr. Pham, what is included in this box?
Including in the box will be one power supply. On the tune you need, on the IC you need for the lab. DMM. Only one thing. The circuit, the breadboard. Who already have it, you go okay. The other one, then you have to buy for $20.
How big are the breadboard?
If you already get one, that's okay. You don't need that.
Does it have to be the full size one that you suggested we purchased last semester?
Can you say again? I couldn't follow it.
Can it be any size, or does it have to be the size breadboard
size-
that you
The
suggested last
size we're
semester?
using at the school.
Okay.
The thing is that size will be good enough to cover too many IC. If you're
Okay.
using a small one, they cannot.
Now for the power supply, is that
Thank you.
DC power supply, right?
Right, DC power supply, and that only 5 volt.
On 5 volt. Okay, yeah.
Yeah, we get a power supply for you guys.
You have enough of that?
That's what we're supposed to.
Okay. Because if-
Otherwise, if I take how many I get right now, then maybe my assistant, Mr. Sam, have to spend the time to make enough for me.
okay. Okay.
And you cannot using a different power. You can connect. You can cook the box.
Yeah. And then tools, what tools are we talking about?
The tool will be the cut the wire.
Oh, the cutter, okay.
That means anything need in order you guys can do the lab.
For some of you, you probably have your own tools, but typically you need like wire strippers. You need
That's what.
you need needle nose, that type of thing. Maybe
Right.
like a baby screwdriver.
Right. Whatever need for the lab, we will support to you.
But you did say, Mr. Pham, that you were still looking for some items, or?
No, it's not some item. Only thing the
You have everything on?
everything will be ready.
No, I know, but
You're
did you
bringing the
say
strippers.
earlier? Oh,
Only thing power supply. The thing away is in the solid power supply. Okay, if you short it, they can be die for a while, but they not cook anything. You know, those power supply in the too many years ago. One student working in the company, they make that power supply and they not eating anymore. So he bring it to me. So that is a perfect power supply for digital testing.
Now I noticed we have something like 30 some student in class today. So does that mean everybody's going to get a box, or is it only
No,
limited?
no, that means you doing this week, then another round will be doing next week, then you go back. Okay,
Okay.
that take a turn.
Okay. All right. Thank you.
Do we need to sign in for that, Mr. Pham?
Yeah, when you can take out the box, you need to sign.
Okay.
So, you know, my assistant will be take it out. You know,
Yes.
when you
Yeah.
return, have to take it to see and they miss it.
If anything is missing, Mr. Pham going to charge you 10 times what it's worth.
And
Well, you will
also,
go get your certificate.
you understand we get 12 systems for left vote and also extra for on of the cleaning. Okay, whatever for the cleaning. Okay, then my assistant, when you return, they have to clean everything, put to the box to make sure safety for everyone.
Mr. Pham is telling you guys don't get no COVID-19 on his stuff.
You guys, some people enjoying okay. I am get older.
So,
So
Mr.
that's fine.
Are you going to be showing us how to put the circuit together on a breadboard tomorrow?
Yeah.
Tomorrow?
Must be teaching you. The people already knew it. That's okay. But the people knew we have to teach how to put the IC, how to connect the wire, how to connect into the test box, okay, and how to run the program.
So that would be next week, or?
No, you have to get your lab first. Then you have to do everything.
Okay. So
Everything means what? That means you have to run piece file, you have to collect output data, and you enter, okay, the Excel. And on the Excel, you can get more things. When we start on the lab, I will be go through each one.
Okay.
To teach you. Then after you're done for Excel, you get pass. Now you have to coding your program. Okay?
Yeah.
And you coding your program and you must be uploaded. So we verify your software first. Make sure your software run the lab they pass. Then now you build your circuit. If you run it fail, that means your hardware is not your software. Otherwise, both unknown. You don't know your software okay, or your hardware okay cannot do it. Okay? That is the process takes for a while at the beginning. Later on, when you get along, then no big deal. They just do it, repeat the same thing for any lab. Okay, any question anymore? Otherwise, we'll see you next week.
Thank you, sir.
Yeah, okay, thank you.
Thanks, Mr. Fan. Bye.
Have a good weekend. Okay.
Thanks,
You too.
I see you tomorrow morning at 9 o'clock.
Thank you.
Thank you.